Hi, we're going to look in this video about subatomic particles and the periodic table. So just looking at how does our model of the atom with the protons, neutrons and electrons relate to the periodic table, and these numbers we get on the periodic table for each element, what do they mean? Alright, if we look at the periodic table, which is showing us the different types of atoms that there are, we notice that for each of these elements there are two numbers given. First of all, we've got this one which is going up by 1 each time, and our key here tells us that that's called the atomic number. We notice always, if you look and compare the two numbers for each element, that it's always a smaller number that's the atomic number out of the two of them. And that's the way to remember it. It's the atomic number is a smaller number. It's important to remember it that way rather than remembering which number's the top number and which number's the bottom number, because annoyingly some periodic tables have it the other way round and they'll have the mass number at the top and the atomic number at the bottom. So watch out for that one. When you're looking for the atomic number, always look for the smaller of those two numbers, which means that the bigger one is the mass number. Okay, what does that actually tell us? Well, remember what I said earlier in the other video, which is that the element is defined by the number of protons it has. And this atomic number defines each element, and it's often called the proton number. The atomic number just tells us the number of protons. So if an atom had 1 proton, then it's a hydrogen atom. If an atom had 28 protons, then it's always a nickel atom, for example. So that's what our atomic number is. It just defines for us the number of protons. If we're considering the mass number, if this is about the mass, we remember that it is the protons and neutrons that have a mass. So the mass number tells us the number of protons plus the number of neutrons. Electrons we ignore because they're so tiny they don't affect the mass. So the mass number is the number of protons plus neutrons. Okay, so now we can look at how do we work out number of protons, number of electrons, number of neutrons. We've already said that the number of protons, we just look at the atomic number on the periodic table. So we look at the small number. Now, the number of electrons. Atoms overall do not have a charge. And that's because the number of protons is always balanced out by the number of electrons. Protons are positive, electrons are negative by the same amount. So if an atom had, for example, 5 protons and had a plus charge of +5 in the middle, it would also have 5 electrons and have a -5 charge. And they balance each other out, so overall the atom is neutral. So therefore, we know for an atom, the number of electrons is always just going to be the same as the number of protons, so that those two charges can balance out. So number of electrons, really simple, we're also just looking for the small number. Number of neutrons then is the only one that we actually have to work out, and that's going to be very simple. The mass number tells us the number of protons and neutrons combined. The atomic number is just the number of protons, so to find the number of neutrons, we just have to do the mass number take away the atomic number. Or in other words, we just have to do the big number take away the small number. Okay, so that's really simple, and I'm going to do it for just these 4 example atoms here. So first one, really classic example, is carbon. The atomic number, I can tell it's the atomic number because it's smaller, is 6, and the mass number is 12. So the number of protons is just the atomic number, which is 6. The number of electrons is just the atomic number, it's 6. And the number of neutrons is going to be 12 take away 6, which is 6. So in this case, the number of protons and electrons and neutrons is the same, which is often the case. For lithium, 7 and 3 are our numbers. So protons is just the atomic number, the smaller number is 3. To balance that out, the number of electrons must also be 3. And the number of neutrons is going to be 7, take away 3, which is 4. So we've got a different number of neutrons to protons in this case. Hydrogen's an interesting one. Hydrogen's the simplest type of atom. It's got an atomic number of 1, and this atom's got a mass number of 1 as well. So protons, we just look at the smaller number. Well, they're both 1, so it's got to be 1. And the number of electrons has got to be 1 as well. To work out the number of neutrons, one of these is the mass number and one of them is the atomic number, but they're both the same. So either way, it's going to be 1 take away 1. So the number of neutrons for this atom is 0. There are no neutrons in this atom. It's just 1 proton and 1 electron. Last one, just to show you if it's a slightly more intimidating example, it's exactly the same. It's still really easy. So this is a uranium atom, and the number of protons is still just a smaller number, 92. The number of electrons, again, is going to be 92. And the number of neutrons is just going to be 238, take away 92, which is, I believe, 146. Okay, so there you go. That's how to use your periodic table to work out the number of protons, neutrons, and electrons in atoms.